Now, let's move to the section 2 of the chapter 6. And in this section 2, we will verify more identities. So the whole section is about verifying identities. And before we say two expressions, f1 and f2, right, are equivalent if and only if f1 equal to f2 is an identity. Okay. So now let's look at some example. And let's go to the page 524. And we first look at the problem 2. It says we need to match this expression on the left side with one on the right side that completes each equation as an identity. So we begin with the secant x times cotangent x. Let's come back to the whiteboard. So this is page 524. Number 2. We have the secant x times cotangent x. And we try to simplify this expression. So we just rewrite the secant and cotangent in terms of the sine and the cosine. So for the secant, we use the reciprocal identity 1 over cosine x, right? And for the cotangent, we use the identities from the definitions. And it is equal to cosine x over sine x. Now this guy cancel, so you have the 1 over sine x, right? And then we know by the reciprocal identity, this is equal to cosecant x. Now let's go back to the book. So cosecant x, this guy, part I, right? So part I corresponds to the expression in the problem 2. Okay. So this guy corresponds to part I. Now let's look at the number 10. Sine x over the cosine x plus the cosine x over the sine x. And first, we try to reduce these two fractions to the common denominator. So the LCD, the least common denominator, is the product of these two denominators, right? You have the cosine x times sine x as the LCD. So right now, we need to also multiply this numerator by this sine x. So you have the sine square x, right? Actually, if you cancel one factor of the sine x from the numerator and denominator, then you just go back to this arrangement. And similarly, for the second fraction, we multiply both the numerator and denominator by the cosine x. So we have the cosine x times sine x. Then the numerator is the cosine square x. So now, these two fractions have the common denominator. Then to add these two fractions, we may just add the numerators and then put the sum over the common denominator. So you have the sine square x plus cosine square x. And over this common denominator. Now for the numerator, we can apply the fundamental identity, which is equal to 1, right? So then you have the 1 over cosine x times sine x. Then let's check the right side. 1 over the sine x and the cosine x is part f, right? So this guy corresponds to f. Now let's look at the problem 26. Find the products and simplify your answers. So 26 is the cotangent alpha minus the cosecant alpha times cotangent alpha plus cosecant alpha. Which special product formula should I use? The product of the sum and difference, right? So you have the a minus b times a plus b equal to a squared minus b squared, right? So now in this product, your a is the cotangent and your b is the cosecant. So a minus b times a plus b. Then you get the a squared cotangent square alpha and then minus b squared cosecant square alpha. Now this guy equal to what? 1 or something else? Remember one of the Pythagorean identities here, right? Cotangent square minus the secant square is equal to -1, right? So this guy, cotangent square minus the cosecant square is equal to -1. And then done. Now let's look at the (36). And in the 36, we need to fact this expression. Okay. So let me copy this problem on the whiteboard.